Hello, 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 hello. Good evening, good morning, good afternoon. Welcome to another lecture. Right, great. So, we are going to do a few things now, and one of those things is that we are going to study. That's the point. Yes, we are going to study. Such a beautiful thing we are going to do. We are going to study. Right, I'm not sure what were you doing up until now, but now we are going to study apparently. Right, fine. So in last class we have solved some questions based on miscellaneous graphs. Right, so we have completed the miscellaneous graphs part. Now to further understand the topics, or yes, to further understand the upcoming topics, we need to know calculus. We need to know calculus in the sense we need to know certain mathematical operations, right? So what is going to happen now? What exactly are we going to study? Calculus, if you are in 11th standard, it might sound a very new, very strange, I don't know what sir is talking about, right? So I'll tell you roughly, I'll give you an analogy what exactly we are going to do now. Okay, I'll give an analogy about points that what exactly we are going to do right now. Fine. So see, what we are going to do here is we are going to learn a new mathematical operation now. Okay, we are going to learn a new mathematical operation. Like for example, you know how to add, you know how to subtract, you know how to multiply, you know how to divide. You know multiplication, subtraction, addition, division, all these things you know. Those are nothing but mathematical operations. Now you tell me, can you solve any question, any numerical question without knowing addition, subtraction, multiplication or division? Right? No, right? I'm sure we cannot solve any question without the use of multiplication, subtraction, addition or division. No, yes or no? So same way there will be certain questions which will require two new mathematical operations, either any one of them, either differentiation or integration. So if you do not know differentiation or integration, then you may not be able to solve certain questions moving forward. In the upcoming topics there will be certain questions where you have to use these mathematical operations to solve those type of questions, right? So it is very important for us to learn these two mathematical operations which comes under the branch of calculus in maths, right? So let us see what this thing is all about, right? What these things are all about that we are going to study, right? Okay, let us see. So first thing that we are going to study is, so see, calculus is a branch of mathematics. Okay, so if we write it in detail, just a rough brief understanding we'll have. So we are talking about calculus, right? Fine. So calculus is a branch of mathematics. Branch of mathematics in the sense, you know, we have algebra, trigonometry, what all, coordinate geometry. All these are like branch of mathematics. There are different branches of mathematics, you can say. Similarly, we have another branch of mathematics called calculus. So calculus is also actually of two types. Okay, it is further divided into two categories, you can say. One is differential calculus and another is integral calculus, right? So there are two categories here. Right, let us see. First one is differential calculus. Another is integral calculus. Fine. Differential and integral calculus. So basically differentiation and integration. Under differential calculus, we study differentiation, maxima, and there are obviously some related continuity, differentiability. Again, that's pure mathematics. I'm not going to mathematics part right now. we have to focus on physics. So under differential calculus comes the differentiation, and under integral calculus comes integration. That is what we are going to focus here. Okay, so under differential calculus we have differentiation, fine, and under integral calculus we have integration. Fine. Okay, great. Okay, let us move ahead. So now first we are going to talk about differentiation, and then we are going to talk about integration. So the first major topic that we have next is differentiation. Fine. Fine. So now let us try to understand what exactly is a differentiation. Fine. So in basic terms, what differentiation helps is, differentiation helps us in finding slope. Okay. Differentiation helps us in finding slope. So first let us talk about slope a little bit. Okay. First let us talk about slope a little bit. Yeah. Right. So slope, you know, what is slope? What exactly do you know about slope? So we'll take two cases. First we have slope of a straight line. Okay. First we're going to talk about slope of a straight line. Straight line, right? Simple thing, short thing. Okay, great. Fine. So what do you mean by slope of a straight line? So let us talk about this. Let us put some light over it. You know? So slope in general, like if you go by the literal meaning or by the English meaning of slope, so what exactly is slope? Slope is what? Inclination. Yes or no? So if you have any surface which is not horizontal, which is at certain angle with the horizontal, we'll say that it is a slope. Yes or no? Right. So the same thing. So suppose this is a straight line. Let us take, let me draw a straight line. Fine. Suppose this is a straight line. Fine. What will be slope of this particular straight line? Right. Suppose this is a straight line. How do we figure out the slope of this particular straight line? Okay, this is x and this is y. Fine. Yes or no? Now, how do we find slope of any straight line? Slope of any straight line is basically the tan of the angle theta that it makes with horizontal. Okay, this is a straight line. Now how do we find slope? So obviously slope, measuring slope means it will give us an idea that how steep the slope is. You know, so in a way you can say that slope is trying to measure the steepness of any curve or any straight line. You know, what is slope trying to measure? Slope is trying to measure the steepness of any curve or any line. Yes or no? So how do we measure the steepness? So obviously you can understand, higher this angle, and suppose let us take this angle, it is making some angle theta with the horizontal, right? So higher this angle theta, higher will be the slope. Yes or no? You agree? Higher this angle theta, higher will be the slope. But mathematically we do not measure slope as just the angle theta. We actually measure the slope as tan of this angle theta. So how do we define slope of a straight line? So slope of a straight line is simply the tan of this angle theta. Okay, slope of a straight line is tan of this angle theta. Fine. So that's the thing. So mathematically we have defined slope as tan of this angle theta, and slope we also represent by small m. Okay, Just keep this notation in mind. So in standard form, we also represent slope by just small m, right? Great, amazing. Now, so you can also say that m will be equal to tan theta. Fine. So see, tan theta is an increasing function. So as theta increases, tan theta also increases. Fine. So if theta is 0 degree, and if the straight line is completely horizontal, then the angle that it makes with x-axis is 0 degree, and tan 0 is 0. Fine. And as the angle increases, the tan theta value will increase. So as the angle increases, the slope value will also increase. So you don't have to worry about it, right? Okay, clear. Now, so here what exactly is theta? So now there is a convention that we follow. So we could actually measure angle from this side also, like it is making some angle 30 degree from positive x-axis, so it will also be making some angle 180 minus 30, that is 150 degree with negative x-axis. So here what exactly is theta? How do we measure theta? Theta is the angle made by the straight line in anti-clockwise sense from positive x-axis. Fine, but it's theta here. Theta is angle made by the straight line in anti-clockwise sense with positive x-axis. Fine, right, great. Okay, so that's that. So if you have a straight line, so the thing about a straight line is another important point. I'll like to note it down here. So the thing about straight line is that the slope of a straight line is a constant value. Okay, the slope of a straight line is a constant value. So if you have a straight line, it has a fixed slope. Okay, so the next point here is that slope of a straight line is constant or fixed. You can say that slope of a straight line is constant. Fine, slope of a straight line is constant. So that's the point here, right? So see, finding slope of a straight line is very easy. We simply have to figure out how much angle it makes in anti-clockwise sense with positive x-axis, and tan of that angle becomes slope, right? Tan of that angle becomes slope. Now let us see how to find slope of a curve. Okay, next is how to find slope of a curve. Fine, so if it is not a straight line, if we have a curved line, then how can we find slope of a curved line? Right, so the curve will look something like this. Right, suppose this is a curve. Now how to find slope of a curved line, a curve like this. Fine, now here comes the tricky part, right? For slope, for a curve, finding slope becomes little tricky. How it becomes little tricky? So let me tell you. Now see, if it is a straight line, things are very simple. Things are very simple and very straightforward. If you have a straight line, It makes a fixed angle with positive x-axis, and tan of that angle becomes the slope, right? Now, if you have a curve, how much angle does a curve make with x-axis? How can we figure that out? How can we figure out how much angle this curve is making with positive x-axis? Not easy, right? Fine, because the angle is not fixed. As you can see, the curvature is varying. So obviously the angle that it is making with x-axis cannot be a fixed value, right? So see, the thing is that whenever they're asking you to find the slope of a curve, they will never ask the question directly. They will never say simply find the slope of this curve. Okay, they'll always say find the slope of this curve at a particular point. Okay, they'll always ask, or they'll always say that find the slope of this curve at a particular point. So suppose you have to find slope of this curve at x equal to x1, let us say. Fine, you need to figure out how much will be slope of this curve at x equal to x1. Now how do we figure out the slope of this curve at x equal to x1, right? So for finding the slope of this curve at x equal to x1, what you have to do is you have to draw a tangent at that particular point. So corresponding to the point on this graph, corresponding to x equal to x1 point on this graph, what you have to do is, what you got to do is, you have to draw a tangent. Fine. So you can draw a tangent something like this. Fine. Right. So now suppose this tangent is making certain angle theta with x-axis in anti-clockwise sense. Okay, suppose this tangent is making certain angle theta 1 in anti-clockwise sense from positive x-axis. So that means, that does not mean anything, but it means is, what you have to do is, you have to first draw a tangent, and then you have to see that how much angle that tangent is making with positive x-axis in anti-clockwise sense. Then the tan of that angle theta will be the slope. So slope at x1, okay, slope at x1 will be equal to tan of this angle theta 1. Fine. Slope at x1 will be tan of this angle theta 1. So if you have to find slope at x1, what you have to do, you have to find the tan of the angle theta 1. And slope, similarly, if you want to find slope at some other point, suppose if I take another point x2, let us say. Fine. So there will be a corresponding point on this curve. There will be a point corresponding to x2 on this curve, right? Now what you do is, you draw a tangent at this particular point. Fine. What you do is, you draw a tangent at this particular point. Fine. Now the angle that this tangent makes with positive x-axis, suppose that particular angle is theta 2. Fine. So what you have to do, if you want to find slope at x1, you draw a tangent corresponding to a point x1. If you want to find slope at x2, you draw a tangent corresponding to the point x2. Then slope at x2 will become the tan of the angle that it makes with positive x-axis at x2. So at whichever point you need to find slope, you draw a tangent at that point, and then you find the tan of the angle that the tangent makes with positive x-axis. Fine. So slope at x2 will become tan of this angle theta 2. Fine. Slope at x1 will be tan of the angle theta 1, and slope at x2 will be tan of the angle theta 2. So as you can see, as the theta value increases, the slope value also increases. As the theta value increases, the slope value will also increase. So this is like a curve with an increasing slope. So since theta 2 is greater than theta 1, tan theta will be greater than tan theta 1. Anyhow, so the point here is, the main point here is that as we move from left to right, you can see the slope is varying, and at different points when you draw different tangents, the angle that it will be making with x-axis will be changing. So because of that, the slope will be changing. Then the slope becomes variable. Now when the slope is variable, things get very complicated. Whenever you need to find slope at any point, first you draw a tangent, then you measure how much angle it is making with x-axis, then tan of that angle theta will be the slope. So for every point you need to keep on drawing tangents to find slope. So you can understand how big or clumsy process that becomes, and the chances of error are also very high. So the tangents that you draw, even the tangents that I have drawn, I don't think the tangents are perfect. So similarly, when you are trying to manually calculate the slope, geometrically when you're trying to calculate the slope, the tangent that will draw, it may not be perfect. The angle that you will measure, there could be some error there as well. Yes or no? So there are a lot of chances of error when you're trying to find the slope in this geometric manner for a curve especially. For straight line, we can still be very much accurate, but for curve, things get very complicated. So this is where differentiation comes in. Differentiation makes finding slope of any curve very easy. Fine. So here one important point I will note down, that if you have a curve, its slope is variable. Fine. So slope of a curve is variable. That's the point. Fine. Slope of a curve is variable. That's the point we are talking about. Clear? So how we find the slope? With the help of differentiation. The differentiation will actually help us in finding the slope. Yes or no? And it makes things, the process very easily. Finding slope with the help of differentiation is very easy. So how exactly differentiation helps us in finding the slope, that we'll figure out in the next lecture. So I'll keep this lecture very short, very crisp. It's very late at night that I'm shooting right now. I need to go to sleep. Fine. So very crisp lecture, I'll keep this one. So we'll see how exactly differentiation helps us in finding the slope. Yes or no? So if you want to know, do check the next video or the next lecture. So for today, I'll keep it till here. Okay students, thank you, bye bye, good night. Yes or no? Study hard, do well. I'm sure you all are doing great.